I'm Villamar Ghani.
And this is Rogelio Bacat.
We're Team 11 and this is our Project 2. The three types of filters that were assigned to us was a stepped and stubbed low-pass filter and a coupled bandpass filter. Of these three types of filters, we decided to fabricate a 3 decibel equal ripple stepped impedance low-pass filter. The filter was designed to have cutoff frequency of 4 GHz and attenuation of -30 decibels at 5.6 GHz with a characteristic impedance of 50 ohms.
We then designed a low-pass prototype filter by finding the N values by looking at Posar's 3 dB equal ripple prototype on figure 8.27b. The N value was found by choosing the curve that satisfied a calculating normalizing impedance and -30 dB attenuation. The N value that we got was 5. Then the elements of the low-pass filter was found by looking at table 8.4 labeled with 3 dB equal ripple. The prototype element values was used to calculate the scaled values of the lump element in our low-pass filter. The figure that is shown is a schematic of our low-pass prototype filter.
This figure shows what we just explained. Next, we implement the stepped impedance by using transmission lines. We chose high and low impedances of 95 and 9 ohms. To calculate the electric length, we used the equation 8.86 in Posar. Here is the plot of our input return loss and our gain.
This schematic shows the microstrip layout of our final filter. The length and width of the microstrip was calculated by using line calc in ADS. And also the length of the microstrip was tuned to compensate for the fringing effect when you add discontinuities. This is the results of the microstrip filter. Using ADS to generate a layout of the filter, we showed the 1-to-1 scale to Andy and got our supplies. We chose a single-sided RT Duroid 5880 with thickness of 31 mm with a dielectric constant of 2.2.
The method we chose is zombie method. The supplies we needed was copper tape, Kapton tape, solder, the craft cutter, and Mr. Zombie himself.
We then cut the copper tape, place a piece of Kapton tape on top of the copper layer, and align it on the printer, placing the filter design on the copper tape.
This is what it looks like when it comes out of the craft cutter.
Next, we have to carefully take out the extra copper pieces outside of our filter design. Once that was done, we place the copper tape on our blank side of the substrate. And then we take off the Kapton tape, and then finally solder the connector onto our filter.
This is the final product of our filter. We then met up with John Dang, where he took measurements of our filter so we could compare it with our simulated values. We were then able to upload our S2P file onto ADS to show our measured results. Here are the comparisons between our measured and simulated results.